given. Let's read the question. So the question says an object of 5 centimeter is placed at a distance of 20 centimeter in front of convex mirror of radius of curvature that is given as 30 centimeter. Now we need to find the position, nature and the size of the image. Now how can we draw convex mirror? Now convex mirror is showing us like this, where reflecting surface or the shining surface is outward and rough surface is inward. Now center is the imaginary line, that is principal of axis. Now on principal of axis, so this is convex mirror. Now on principal axis, as we know, we can write as pole P, F and C. F is focus, C is the center of curvature. Now what is focal length? Focal length is the distance between pole and focus, and that is represented by F. Now for this we can take as number line. So this is number line, this one and this one. Now for number line, right side is positive and left side is negative, as we can write 1, 2, 3. So left side is -1, -2 and -3. So focal length will be negative here. Now let's write what we have given in this question. First it is stated that an object is 5 centimeter. 5 centimeter is the height of the object. So we can write height of the object, that we can denote it as HO. The value is 5 centimeter. Now next what we are given, that object is placed at a distance of 20 centimeter. So the object distance is given as, object distance is represented by U and the value is 20 centimeter. So object will always kept at left side. This is left side and this is right side. So left side is negative always. So we're gonna take -20 because object is left of the mirror. Now next what we have given, that is in front of convex mirror and the radius of curvature. So we have given radius of curvature, that is represented by capital R. Now the radius of curvature is the distance between the pole and the center of curvature, represented by capital R. So the value of R is given as 30 centimeter. Now radius of curvature is in right side and right side is positive. So we're gonna take this as +30. Now as we know the relation between radius of curvature and F focal length. So as we know radius of curvature is equal to twice the focal length. Focal length. So we can write this as R is equal to 2 times of focal length. Now as we have value of R, so from this we can write F will be equal to R divided by 2. Now substituting the value of R here, so R is 30, that is divided by 2, so we get 15 centimeter and that is in positive. Now what we need to find? We need to find position, nature and size of the image. So first we need to find the image distance. Image distance, that is denoted by V, and we need to find the value of V. Now as we have relation between U, V and F, and that is using mirror formula, that is 1 upon V plus 1 upon U, that is equal to 1 upon F. Now we need to rearrange this for V. So 1 upon V will be equal to 1 upon F minus 1 upon U. Now substituting the values here. So 1 upon F, value of F is 15 minus 1 upon U, value of U is 20 centimeter. So minus 20. So we can write as minus 20. Now we need to solve this. So this is 1 by 15 minus minus plus 1 by 20. Taking the LCM of 15 and 20, so we get 60. Now 15 is 3 times of 60 and 3 into 1 is 3 plus 20 is 3 times. So 15 is 4 times of 60 and 20 is 3 times of 60. So 3 into 1 is 3. Now after solving, 4 plus 3 is 7 divided by 60. On left hand side we have 1 upon V. Now you need to note that you need to find the value of V. So we need to reciprocal it. And denominator will be numerator. So 60 will be divided by 7. So after solving, we get the value of V, that is image distance. That is in obviously positive. The value is 8.57 centimeter. Now as we can see that the image distance is positive, so the image, we can see that for positive, the image is formed behind the mirror. Behind the mirror, because image, this is number line, so this is positive side and this is negative side. So if image is formed behind the mirror, that means the object is positive, image is positive in nature. That means, or we can say that image is formed on its right side. So since the image is formed behind the convex mirror, therefore we can say that nature of the image. How can we say that? The nature. So if the image is in left side or the value is positive, then the image will be virtual and erect. Now next, to find the height of the image, we are going to use the formula of magnification, and the magnification is represented by small m, and that is equal to minus of image distance divided by object distance. Now we have both values, so substituting the values, so minus image distance is plus of 8.57 divided by U is object distance, that is given as 20. Now the minus minus turns to plus, so we have to divide 8.57 divided by 2. So after solving, we get the value of m, and that is positive 0.42. Now we have another magnification formula, magnification that relates the height of the image and the object, and that is m is equal to height of the image divided by height of the object. Now as we have magnification, so we can put the value of magnification, that is 0.42 equal to, we need to find the hi, that is height of image, divided by ho, height of object, we already given in this question, that is 5. Now reciprocal it. After reciprocally, we get hi, height of image, will be equal to 0.42 multiplied by 5. After solving, we get the value of height of object, and that is 2.1 centimeter. So we can conclude that the height of image is 2.1 centimeter. Now from this we can conclude that the positive value of image height indicates that the image is erect. Therefore the image formed is, so the image formed is erect, and that is virtual because image is made in left side, and smaller in size, as we have HI value is 2.1 and HO value is 5 centimeter, that is given in the question. So 2.1 HI is less than HO. Therefore, the nature of image is smaller in size than the object. So this is the required solution. Hope you find the video useful. Thank you.